Overview of Curve Sketching by Justin D'Souza. The learning objective of this lesson is to sketch the graph of a given function using its properties and its first and second derivative. Now, if you look into this lesson, you will realize it's somewhat similar to the previous lessons, previous videos which we have looked into. That is about the critical points, increasing in maximum, increasing and decreasing functions, and concavity. So these three together makes this lesson. It seemed like the last lesson where we do the 5 steps. We will see it now. But in this particular lesson, you will see why this is very important. Because sometimes there won't be a proper graph generated with the graphing calculator. But this method gives us the definition of graph and makes us understand what exactly happens. Here, in order to do this lesson, we need to do these things, basically finding the domain, vertical asymptote, first derivative, second derivative, vertical tangent lines, horizontal asymptote, intercepts. Instead of all this, I will just tell you a method. You can just follow that, and that is more than enough as well. That is what we have done in the previous lessons. Now we can use the 5-step method to solve any problem in this chapter. It's just that the steps will remain same, the values changes, so the derivation changes, and there's some information extra needed for the other problems. Now we'll start with the basic one, polynomial. So step 1, very easy to derive polynomials, isn't it? Derive this f dash of x. What happens here will be the 4 comes down to be 4x cubed plus 18x squared, 3 times 6 is 18, plus 24x plus 8. This is the first derivative. Now we know in order to find the critical numbers, we need to equate this to 0. That is, the first derivative must be equal to 0. Just write it over here, f dash of x must be equal to 0. So x cubed plus 18x squared plus 24x plus 8 must be equal to 0. Now equate this in the calculator. Now we need to just press mod phi. There are plenty of options. Now look at the equation. This is having power 3. Which is the option that gives us power 3? That is the fourth option. So let's press mod phi and 4. Now the first A, B, C, D, there are 4 options. The first one is the coefficient of highest degree, that is x cubed. Next will be x squared, x, and lastly the coefficient, the constant, sorry. So coefficient of x cubed is 4, 18, 24, and 8. What are the answers? Maximum we can have 3 answers. Let's say the answer is negative half, minus 2, and that's it. That means one of the root is having multiplicity of 2 times, but that means basically there's only 2 solutions. It's fine. You can have up to 3 solutions, okay? Negative half and minus 2. So let's try the x values. X can be equal to negative half and x is equal to minus 2. Now what we do is we draw the number line for the step 2. Step 2, it's a number line like this. Sorry for the crooked line. It's something like this. Now we need to write it in ascending order. So lowest number is minus 2 and then comes negative half. Now here we need to take test values. What does this test values mean? Test values would be any values within this range. So minus 2 is here. I can take any value less than minus 2 till minus infinity. Let's take the nearest one because it's easy to calculate, minus 3. Over here, any value between minus 2 and negative half would be minus 1 and lastly 0. And what do you do now? You need to take your calculator back, put this equation and calculate at these test values. How we do is go back to mod and 1, it'll clear off. Now all you need is this particular derived equation. It's 4 alpha x cubed. Then you have plus 18x squared, 18x squared plus 24x plus 8. This is the derived equation. In step 1 and 2, we use the first derivative. This is about the first derivative information. We have typed this equation as it is. Calculate now at negative 3. We're not interested in the answer value. We are just interested in the sign of the answer. That is negative. Now I will show you can take any value until negative infinity. Let me take a bigger value, say minus 20. You will have minus itself. Doesn't matter what, you will have minus. So here you need to mark this first part as minus sign. Okay, at my less than minus 2, it's minus sign. Now change the calc and write minus 1. It's again negative. So here also it's minus, and then we can calc at 0. That will be plus because 8 is remaining. Calc at 0, or you can do it any other positive number. Sorry, let me take this random number. You can see the answer will be positive. So here again it was minus at this case and then plus. So what do we understand from here? The function is basically decreasing. The graph of this function is decreasing, decreasing and increasing. So there'll be a minimum point at negative half. What's next? Next we move on to the step 3. Now this is about critical values. This is about increasing and decreasing functions. Now we move on to the step 3. Step 3 is about double derivation. We have derived it one time. This is the first derivative. Now its second derivative, that will be f double dash of x. That will be just deriving this equation. 3 comes down to be 4 times 3 is 12 x squared plus 36x. And then we have plus 24. This is the double derivative of the given equation. Now we got it over here. What's the next step? The same thing what we have followed up. F double dash of x will be equal to 0 to find the inflection point. So just equate this 12x squared plus 36x plus 24 equals 0. You should use your calculator now. All you need is mod 5 and 3 this time because it's quadratic. Power 2 is in the equation 3. And put in the coefficients 12, 36, and lastly we have 24. The values are minus 1, minus 2. So you can just write over here x is equal to minus 1 and x is equal to minus 2. Now we need to do this number line here. Let's draw a line, and again it's a crooked line. Just let me just draw. Okay, again it's a bad line, but just manage with it. It's minus 2 and minus 1. Now we'll take the test values. What are the test values to be taken here? We will take less than minus 2. That can be anything like minus 3, how we took up above. Here we can take minus half or 0.5 and last is 0. I'm so sorry, it cannot be minus half. It can be 3 by 2 or 1.5. Okay, this is minus 1.5. Half will be after this. You can take 0, 0.5, anything over here, negative half also. So this is the test values. Now how do we find the values, the signs over here? All you need to do is put this double derived equation in the calculator. You need to go to computation mode. Now let's type this out. It's 12x squared plus 36 alpha x plus 24. And what we will do is we will calculate at the minus 3 value. That's 24. It's positive. We don't need the value. It's positive over there. Let's do the others as well. Calculate at minus 1.5. It's negative. It's positive, negative, and let's see the last one. It'll be positive over here. Why? Because this becomes, all these two will be 0, right? Calculate at 0, positive. So what do we get over here? So we have positive, negative, positive. So basically it's concaving upwards here, downwards and upwards. This is what information we have. Now the last step is graphing, but before that, this much over here, finding the x value, step 3. The last number line, which we just now did, can be called as step 4. Now the step 5 would be graphing using the original equation. It's graphing. Now for graphing, we use the original equation. Now here, x and y axis. Now I just realized all are minus values, so more emphasis on the minus. So I'll just remove this line. Let's just have it somewhere over here, and more emphasis on the negative side because all these numbers over here, the critical values, inflection points are at negative. So let's start with minus 2, minus 1, and somewhat half here, negative half. What did I just do? I just wrote these values in this graph. Now this will be 0. This is 0 obviously. What you can do is, the best thing, the minimum points that are required to be plotted are these three. Okay, you need to know the values of these three. So these 3 points, put it in the calculator for this equation. In the sense, instead of x, you need to put -2, and so on. And we need to solve. So let's take our calculators now. Here you need to just put this equation in. See this one, it is alpha x to the power 4 plus 6 alpha x cube, and then we have plus 12x squared and plus 8x, and lastly we have plus 1. Type the equation properly and then calculate it at -2. Now the answer is 1. Now this is not plus or minus. We need to know the value. Imagine this is value we give 1. This is the value. Now let's see the other things. Calculate at -1. It's 0. So at this particular point, it's 0 over here for this. And lastly, we have at -12, calculate at -0.5 or 1 by 2. It's the same thing. You're getting -0.68 somewhere over here. Let me, this is my, okay, I just, this is 1. This is -1. Here it will be somewhere here 0.6. Let me just check the first value, calculate at -2. It's at 1. Yes, positive 1. Okay, I was just confused whether it's -1. Anyways, these are the values we get. Now what exactly, how do we graph it out? We know the first two until negative over here, -half. So I'll just put L over here. So until this point, so you can't see this point anyways, it's not interfering, but just for your own understanding, okay, until this point, whatever is before here, it should decrease. It should come from up to down. Okay, and where is -2? Here, this point, it's increasing. So it'll be, the graph will be something like this. Till this point, it's up. It's decreasing, yes, like this, but it will be opening upwards, something like this. Okay, something like, it's not accurate, but just to have an understanding, something like that. And then from -2 to 1, yes, it's decreasing, but you can see it's downwards. It's like this. It's decreasing only, but it's concaving downwards. You can see there's a difference, right? Now this is important difference. Why? Let me just, now why this is important is because if it was upwards, then it would have been up. Okay, it would have come like this, or it would directly come like this, passing this point, or if it was down, this would be down, up. But no, because of this concavity, we can realize this is the graph. It's not like this. This would be wrong, opposite of this. So it's important, the fourth step 4 and step 2 will tell us how the graph is behaving. Now what about the next thing? We know at -half, there must be the minimum point because it's going down and up. So this is the minimum most point for this graph. And till this point, -half, you can see it is down like this only. Okay, this continues, and now here it changes to upwards. See over here, this continues. Okay, down thing. Okay, I'm not drawing it accurately, but now here this is the inflection point. Here onwards it changes, and now we know where is the value after this. Okay, I forgot to tell you, we need to even graph at the last point. Okay, it's better to graph over here at 0. Why? Because over here we are just approximating. You can take another point, say over here -3, and understand how the graph is behaving. But we know before -2, what is happening? It's decreasing, and over here it's upwards. So it should come from like this, right? I can't have downwards, you know. So this is understood. Even over here, it's basically understood. It's increasing. It's going upwards. Yes, obviously it's going upwards, but I don't know where. Is it 0? Is it minus? I don't know that, right? So what I'll do is, in this given equation, I'll put 0 everywhere. If I put 0, all this cancels. You're remaining with 1. So at 0, the value should be over there. So after this, it just goes up. It zooms up. You know, it's increasing and upwards. So something like this, the graph is going. So you can see it just moves down like this. It's like this, and this is a minimum point, and it goes up. Okay, it's not very accurate, but this is the like crude graph. But this shows you a lot of things. What's happening now? This is the answer. Yes, this is it. this will be the final answer. Now, what about the end points? What is the the end behavior of this particular graph? Is there any horizontal asymptote? This is a polynomial function, so there is no vertical and no horizontal asymptote directly. Only when it's rational you will have that. Over here, asymptote is not required. You get this understanding, it's going on. If you want to know horizontal, if you are finding the horizontal asymptote difficult, taking limit to infinity minus infinity, you can just take a far away point and check how the graph is behaving. That's enough. Now, why do we do this is, now let's look at the answers over here. Look, can you see this graph? This is actually the graph what you get from a graphing calculator. This is how it looks. And you can see otherwise, if you change the scale, this is how it looks. It's very hard to know what is happening. See, we can easily tell what's happening over here, isn't it? Look at this one. You can barely understand it. So that is the reason why it's important for us to know this method to graph and understand very well. Now you can see based on this method, whatever the graph you get over here, see, you can have a more better understanding. This is what is happening, right? It's going up, like that. So this is only found out by overview of curve sketching, where you follow the 5 steps. This is how we solve this problem. I hope this is clear. Now we will do another problem, rational functions. See, all the method is the same thing. The methods are the same 5 steps. It's only the derivation that is a little tricky, because over here you have a rational function. You need to derive this using quotient rule. Let's start solving now. First step, the same steps whatever we did just a while ago. It will be derivation, that is f dash of x. Now here derivation is by quotient rule. Now don't go to take it up. You can take it up by negative power 3 and then it will be product rule, but this is a bigger term, right? So I would personally do quotient rule. So the quotient rule is, if u divided by v is to be derived, it will be u dash v plus u v dash. Now here the above term, it will be derivation of that. It will only be 2x because minus 3 dissolves to 0. Multiplied by v. What is v? It is x cubed. Minus, oh sorry, I've written wrong over here. It's this is product rule. Minus this is divided by, oh, I'm doing blunders over blunders. It's v power 2. I hope this is clear. See, what I had written was about the product rule. The quotient rule is this, minus. Now, keep the above term as it is. That is x square minus 3 will remain. Multiplied with, what is v? V dash. Denominator derived, okay? It'll be 3 into x square. Divided by, what is the square of the denominator? It will be x cubed the whole square. Now, it will be 2x to the power 4 minus, what happens over here? See, this, just be very, very careful. There is a minus sign and there is a term here. So this minus sign is for the entire terms, okay? It's not only for this term, first or second, it's for this entire thing. So what I'll do is, since all is over here, it's again multiplication, use the FOIL rule, that multiply these both here. The next step will multiply the sign. So I'll write the sign outside. 3 times x square and x square becomes x to the power 4 minus 3 times 3 is 9 x square divided by x cube plus x cube times square is x to the power 6. Now we will get 2x to the power 4 minus 3x to the power 4, and plus this becomes minus and minus will become plus 9x squared divided by x to the power 6. So what happens here? I'll just continue it over here down. You can solve this. 2x to the power 4 minus 3x to the power 4. What is the answer? It is negative x to the power 4 plus 9x squared divided by x to the power 6. This is the simplified version, but still you can simplify further. Here what you can do is we can remove this x power 2 common outside, because both is having x power 2, right? So we will remove x power 2 outside, and what's going to happen? You will have x power 2 outside. What's remaining is basically minus x to the power 2 plus 9 divided by x to the power 6 itself. Now we are removing this common. Now if you use the distributed property and multiply it inside, it will be minus x to the power 4 plus 9x squared. It's the same equation. Why we did this is we can cancel this with over here, it will be x power 4 in the denominator. This when it goes on, it's minus 2, so it will be 6 minus 2 basically, the powers. Now here it is a quadratic, here it is power 4. So let's simplify and write, it's minus x to the power 9 plus 9 divided by x to the power 4. How do we find the critical numbers? How do we equate this to 0? We have to equate this to 0 to find critical numbers, right? So this is power 2, my bad, I wrote 9. So we do the denominator separately. See, x minus x squared plus 9 must be equated to 0, and also x power 4 must be equated to 0. Now you can use the calculator mode 53, but this is very easy because it's minus. I know it will be plus or minus 3. That is, not, x goes to the other side, positive. Now take square root on both the sides. It will be plus or minus 3 is equal to x. Taking both square root on both the sides. Next over here, taking root power 4, radical 4 on both the sides. What's going to happen? 0 radical 4 will be 0 itself, but x, this powers cancels off and you will get x. So this is the thing. It is over here plus or minus 3, and over here we get 0 from the denominator. But when we are doing the number line, we need to do all these, all of it. In the sense, all the x values. That is plus, minus 3, and then 0 as well. Let's do it out. Minus 3, if this is 0, then this is 3. And now you need to do the test values. We need to choose test values, say minus 4, minus 1, 1, and 4. Now here you need to put all these values in the derived equation. You can write it over here or any of this, but it's better to use the simplified. This is the simplified one. So put it back over here and find whether it's positive or negative, and then we can move to the next step. Let's see this. Now we will put the test values in the calculator. First, you need to put this equation in the calculator as it is. Minus alpha x squared plus 9 divided by alpha x to the power 4. Sorry, this is down in the denominator, alpha x to the power 4. Now just type this as it is. Now it's up to you. You can even type this equation or the simplified one. It's easier if you put the simplified one. Now calculate at all these test values. Calc minus 4. We don't want the value of whatever this is, this number. We just are worried about or bothered about the sign. So the first one over here is minus. So all you can do is put a minus sign. Same thing goes to the next one. The next test value is minus 1. Here it's plus. Then go to the next one, calc at 1. See here both we got plus. So this is important. Here it was plus. Even over here it was plus. And last one, that is positive 4, was remaining. Positive 4, and it's minus. So these are the test values. Over here it's minus the last one. So what's happening here is basically it's decreasing, increasing, increasing, and decreasing. This is what we get. Now this is step 1 and step 2. So this is what we get in the first set, that is the first derivative information. Now once we are done with this, what we need to do is we need to do the double derivative. So this is done, step 1 and 2. This much is step 1, finding x, and the number line is basically step 2. Now we need to derive it again. We need to use the quotient rule again and solve it. Now what do you solve again? The simplified one, not the any other thing, only the simplified one. So let's do it. I will just erase what we have already done. We will leave this step 2. This is important for us to draft the final graph, whereas this is just for the derivation. So now the step 3 would be the derivation of the simplified form. Now this is f dash of x simplified, what will be f double dash of x? That is the second derivative. Here you will have to use the quotient rule again. You can take this up x to the power minus 4, use product rule, but it just confuses a lot. It's better to leave it like this, and the denominator will be squared for the whole square. That's the rule. And now numerator, first derive it. What happens is this plus 9 becomes 0, but over here you will have minus 2x multiplied with, what is the v? V is the denominator, x to the power 4 plus, sorry, it's minus, I'll put in bracket. Now uv dash, what is u? The above term, minus x squared plus 9 multiplied with the derivative of the below term, that is 4x cubed. So this entire thing will have the minus sign. Now we will simplify this. We have done similar thing just a while ago. So here in the first term, it will just be minus 2x to the power 5, because x and x to the power 4, add the powers over here, it will be 5. Minus. This is multiplied inside. This minus sign, let it be out itself. It will be minus 4x to the power 5 plus 9 4 times is 36x cubed divided by x to the power 4 times 2 is 8. Now you can simplify it further, that is multiplying this minus sign inside will be minus 2x to the power 5 plus 4x to the power 5 minus 36x cubed divided by x to the power 8. Now when you solve it over here, it will be 2x to the power 5, that is minus 2 plus 4 is plus 2 minus 36x cubed divided by x to the power 8. Now take x cube outside as common. X cube is removed out. So what is remaining? You're remaining with 2x to the power square, because 3 is gone. 5 minus 3 will be 2. And minus 36x, 36 only. Why? Because x cube is gone now. Sorry. Now then, divided by x to the power 8. Now you can cancel this. It will be 8 minus 3, that's 5. So you will have in the numerator 2x squared minus 36 divided by x to the power 5. If you simplify this, this will be over here 5. Now this is the simplified version for the second derivative. Now once we have done this, we need to equate the numerator separately to 0. I'll just do it over here. Now it's better to graph over here. So I'll just do it over here somewhere. You need to do numerator, that's the above term, 2x squared minus 36 is equal to 0, and use the calculator and find what is x. You can take 36 to the other side, divide by 2, it will be root 18. To solve this, you can use the calculator mod phi 3 because it's quadratic. Now type in the coefficients, it's 2. There's nothing for x. See, it's not minus 36, it's 0, and now it's minus 36. So the values are 3 root 2, which is supposed to be root 18, and minus root 18, or 3 root 2. So these are the x values in the numerator. So I will just write them out over here. X is equal to 3 root 2 plus or minus. Okay, now it's better to just understand what these values are. It's about 4 point something. You can just press SD. It's 4.2426. So why? Because when we do the number line, it's very important. This is equal to plus or minus 4.24. Now what about the denominator? Just make it equal to 0. X to the power 5 equals 0. When we take radical phi, it will be just 0 both the right side. So it will be x is equal to 0 itself. Whenever it's a single term, any raised to any power, it will be 0 itself. Now we need to do the number line, that is step 4 over here. Step 4. This is all step 3. This was step 1 simplification. I'll just erase it. It's not required anymore. That was the first derivative. We derived it again. Now then, here, just draw a number line. And now if you compare this was minus 3. So minus 4.24 somewhere will be over here. Minus 4.24. Then we have 0. And lastly again positive 4.24. You need to take test values in between this. So I'll take minus 1, 1 over here, and there will be 5 and minus 5. Now, where do you put this test values? Not in the first derivative, in the second derivative. Let's put the simplified second derivative. All you need to do is, let's go to computation mode and type this as it is 2 alpha x squared minus 36 divided by alpha x to the power 5. Here, put these test values, calculate at minus 5. Now we are getting negative answer. This first one is minus to start with, then calculate at minus 1. We are getting plus. Now again calculate at 1, now minus, and lastly calculate at 5. It will be plus. So it was minus, plus, minus, plus. So here in the first part, minus is downwards, upwards, downwards, upwards. This is the concavity. Now it's opening upwards, it's opening downwards. You can see over here it's downwards opening, upwards, downwards, upwards. Wherever it's plus, it'll open upwards, minus downwards. So now with all this information, you can try graphing it out. Now how would you graph it is, first just draw a coordinate, say straight one over here and like this. Let's put in the values. This is 0, important point. Now which is the other points which we need to mark? It's minus 3, minus 4.24. Here the same thing, plus 3, plus 4.24. Now these values you need to put in the given equation. This is f of x. So over here this is step 5. Step 5 is the graphing. We need to use the original equation, the question itself. Okay, so let's take the calculator, type it out as it is. This equation as it is, that will be alpha x squared minus 3 divided by alpha x cube. Now what you need to do over here, you need to put these values and find the y values. In the last step you need to find the y values because we're graphing. Calculate minus 4.24. It's negative 0.2, you can say. Okay, it's very close to 2, so I will take it over here. Imagine this is negative 0.2. Okay, minus. So first value is somewhere over here. Then again calculate it at, let's go to minus 3. It is negative 2.22. So I will take negative, I'll just mark this as 1.9 itself. Now I realized it. That was a bad idea. 1.9. Let me take this as 0.22 minus 0.22. Okay. This one over here is somewhere over here. Same thing at the right. 0 is also important. When you put it as 0, what happens? Now, in all the cases, you can see if you put 0, it's undefined. It's an asymptote there. Now, I'll show you if I put 0, it's undefined. Why? Because the denominator is 0. You cannot have that. So, it's undefined. There'll be an asymptote here. Now, what about 3? It's going to be just the same values but positive, isn't it? So, calculate at 3. It will be positive 0.22, or calculate at 4.24. It will be positive 0.9. So let me just take this over here. Positive 0.19, positive 0.22. So it will be something over here and over here. Now, this is mainly it. Now, if you're not so confident in finding the asymptotes, how exactly it works, so what you can do is, if you're not wanting to find the limit here, you can take more test values. I will show you now. Let's take our calculators back. All you need to do is, the same equation is there, right? Calculate near to this 0, left side and right side. If you calculate near to minus 0.1, it's near to 0. You can see it's 2990. That means what's happening? From here, the point is going upwards. That is what the asymptote is, upwards. If I go very, very closer, minus 0.001, it's going to positive infinity. Whereas, let's see what's happening in the right side. Not negative now, let's take positive 0.01. It's going downwards. This is the thing. So I know this is an asymptote, right? Here, after this, it goes up like this, and whereas over here, from this value, it goes down. If you want to know what's happening before minus 4, you can just calculate at minus 5 or minus 6. It's fine. How much is it? Minus 0.15. So it's coming like this. So if you take another huge value, like an infinite, close to big value, say minus 100, what happened? It's very close to 0, isn't it? It's 0 0.0. So then I can understand easily the asymptote is like this. So you can just put these values out, like somewhere over here. You can just, or write it out. The asymptote, the vertical asymptote is 0. Why? Because the values are showing like this. It's very close. Or you can just take limit towards x of minus infinity and plus infinity, and you will get the same thing. You will get 0.000. So how do you take minus infinity? Just put this as it is and calculate at a huge number. Say, what is happening? It's almost 0.00001. It's very close to 0. So therefore, you can tell there is an asymptote or horizontal asymptote at 0. Now here, with the values we know, we just can't connect them. It's not like this. No. You need to see what this is. Sorry, asymptote. You can't touch it over here at all. You need to see this. Before minus 3, everything before minus 3, it's decreasing. But after minus 3, it's increasing. So you can see there's a dip here, something like this. Because it's the minimum point. Here, whereas this will be the maximum point. At, sorry, minus 3 is over here. Just a quick thing. This should have been at 0.22, I believe. I just think these values are a little bit wrong. I'll just change this. This is supposed to be plus 3 supposed to be at 0.22. My bad. I just double checked it. And this is 0.19. And this will be having the maximum point. From here, we can see it's a maximum over here. Something will be like this. Okay. Now, we need to double check with this. Is it true? Yes. This comes within this range. Yes, it's upwards. This is downwards. Now, there's before negative 4.24. What is happening before negative? It should be downwards, and I know this is having an asymptote, so it'll be something like this. I don't need to draw much over there. It'll be something like this. It's downwards. Can you see that? Opening downwards. Here it changes and opens upwards. This should be opening upwards from here. This point, it should change, opening upwards. And here it just keeps on increasing. You can see it's decreasing till here. From negative 3, it keeps on increasing, and it just goes. It's not so accurate, but just keep on going as an asymptote. Okay. You can draw it more accurately. Okay, that's the thing. It's a freehand, that's fine. Now here, what's happening? The same thing. It's decreasing here right side, and it's opening upwards after 4 points. So now this is all opening downwards till here. Then it opens upwards. Okay, it will be opening upwards like this curve. Open upwards. This is open downwards. This is open upwards. And here we saw it will be something like this asymptote. This is not at all accurate, but you can get the idea of it. If it's not even very accurate, it's fine. But as long as you have written these points, plotted the values, and done the graph, it is more than enough. Now let's see over here if you are drawn it from graphing calculator. This is the graph. This is the rough idea of the graph. I'll just remove it for a while. Now, if you're done in graphing calculator, this is the problem. This is the graph you get. This is the graph. Can you see any detail as what we have got? We have understood what's happening. But here, look at the graph. It's very plain. You don't understand. It's plain and blunt. You don't even understand anything. So that's why the method which we did with all that, first derivative, second derivative information, it's a long method. Now, this is the graph. Yes, we got not very accurate, but it's almost true, right? And see, look at the scale which we're using. Now, here there's different scales. According to the scale, we can understand, okay, this is happening. So this scale and over here, the scale is different. Why? Because we know where it is moving accurately, we have used the appropriate scale. So therefore, overviewing of curve sketching gives us a better understanding of the graph about what's happening over here. The maximum, minimum, the critical points, and the intercepts, everything. So that's how we solve it. Now, this problem is just like what we have done before. Now, From this point onwards, you can do all the others by yourselves. If you're thorough with it, you can solve by yourselves. We have done the rational functions as well in the previous videos, the same concept. Just remember the 5 steps and you can solve all the problems in this lesson. But I will do all the problems, the coming problems as well in details. If you have any problem, you can refer back. Otherwise, you can stop watching from here and solve all the remaining problems by yourselves. Now, before starting to solve this, I will just show you the graph, how it looks over here. This is how the graph looks. I mean, this pretty much, yeah, because the denominator is having square, so you will have two vertical asymptotes, isn't it? Over here, I can look at this and I can tell it's plus or minus 2. Yes, at plus or minus 2, there are vertical asymptotes. But see, this is having more accuracy, but the final graph which we will do, this is telling a lot. Okay, so that is what we will be hoping to get. Now I'll just go back and we will start solving it up. See, this graph also gives us more detail, but the zoomed up graph, the final graph which we did, has more understanding. Now here you can do the vertical asymptotes, horizontal asymptotes separately, or you can just follow the 5 steps and mainly get the graph directly. So now one more thing, if you're thinking from table I'll directly get the answer, that defeats the purpose because you won't get an accurate graph. You know, when you make a table, you will get for different scales, it won't be so accurate. So that's why we need to do first derivative, second derivative, and then graph it. Now let's graph this up with the steps. We will start with the step 1, that is the first derivative, step 1, f dash of x. Here again, we need to use u by v, that is u dash v minus uv dash divided by v squared. That is equal to, over here, denominator is squared, okay, x squared minus 4 the whole square. What about the u dash? That's the numerator, 2x. Derive it down term as it is, x squared minus 4 minus above term as it is, x squared into 2x. Okay, now then after this you need to solve it up. What happens? Multiply this inside. When you multiply over here, it'll be 2x cubed, x squared into x, minus 2 times 4 is 8x. This is done. Now here it's all multiplication, so the sign will be same, only one. If it's only bracket plus or minus, then it's two signs. Now here it'll be 2x cubed divided by the denominator is x squared minus 4 the whole square. Now I'll just try to simplify here in the top because I know this is positive, this negative, it cancels out, and you're having minus 8x divided by x squared minus 4 the whole squared. This is the simplified version. Stop it over here. Now numerator is equated to 0, denominator is equated to 0. Here at the top, when I do the numerator and denominator separately, minus 8x equated to 0, x is equal to 0. Very easy. The numerator, don't go to take this entire thing, because even if you take it's fine. But you know, for the first time, I'll just take the entire thing now. I'll just show you. Whole square is equal to 0. How do you solve it? You take square root on both the sides, isn't it? So it'll be x square minus 4 is equal to 0. Now take this 4 to the other side. X square is equal to 4. X is equal to plus or minus 2. So this is the answer, 0 and 2. But instead of all this every time, what you can do is you can save time just to whatever is inside the square root, because this all will be dissolved when you're equating to 0. So whatever is inside, just that part, what you can do is, I'll now erase this. Only that part, make it equal to 0. See, that is x squared minus 4 equal to 0. You can put this directly in the calculator as well, and you will get x is equal to plus 2 and minus 2. So this is how you can save time. Only whatever is inside in the calculator this time. Now we have to do the number line. We got this x plus and minus 2. So number line, let me just do it over here. The number line will be at plus, minus and 0. Okay, minus 2, 0, plus 2. Take the test values now. Test values can be minus 3, minus 1, 1 and plus 3. Here then we need to use our calculators. Now we will write the first derivative in the calculator, that is minus 8x divided by, first open the brackets and then alpha x squared minus 4, close the bracket and square it up again. Now check all the test values, calculate at minus 3, that's positive. So you don't need to write the values, only the positive or negative, it's plus here. Same thing with the next one, check at minus 1, it's positive again. We will have to do the other two as well. At 1 it is minus, and last one it is minus. So it is plus plus minus minus. This is what we get. Now after that, the next step is double derivative. So this will be the step 2. So step 1 is finding the x values, step 2 is the number line graph. Okay, this is a very important thing. Next, step 3, I'll just write it over here, f double dash of x. So what happens is the simplified one, use this to double derive. Very important thing, please use the simplification, don't keep it huge, because deriving this, it'll be too big. So please simplify how much you can. Now you can go further in simplification by splitting out this. That's not required because I'm going to use the quotient rule again, so you don't need that, but this much is important to simplify. Now here what's going to happen, the denominator will be x square minus 4 the whole square, again the whole power 2. This powers will be multiplied basically. Now what about the numerator? It will be derivation of the above term, that is minus 8 into whatever is down over here, x square minus 4 the whole square, minus, now above term, now I'll use the bracket because there's minus plus, above term as it is, multiplied with the derivation of this. What happens is this will be power rule, 2 times x square minus 4, and then chain rule. See, it's a chain rule. First power rule, done. I've done the power rule. It'll be power 1 over here. Derive whatever is inside, that is 2x. Now, this is all derivation which we have done in the previous videos. So now we will have to simplify this over here. So you can do all whatever is multiplied together and then multiplied inside, whichever method is easy. Now we need to simplify this. But before simplification, what I would personally do is, see, I can see there's x square minus 4 over here in the denominator, x square minus 4 here. There is x square minus 4. I would not touch anything with those because I'll remove that common and cancel it in the denominator. So only solve all the others, whereas leave that x square minus 4. So what I would do is minus 8 into x square minus 4 the whole square, minus, let it be outside the bracket. Here, let's solve all the numbers. It's 8 times 2 is 16, 16 times 2 is 32, minus 32, x and x is x square multiplied by x square minus 4. Okay. Then over here denominator is x square minus 4 the whole square, and square becomes 4. 2 times 2 is 4. Now the sign when you multiply in, what is going to be, this is all a multiplication term, it's just going to be plus. So what I'm going to do is I'm going to just change it, Don't do that in the exam, just make sure you multiply and write it as another step. Here this is going to be plus. Why? Because the entire term is one term, it's multiplication. So if I put over here, there was minus, minus, just becomes plus. This is it. This over here was minus itself. Now look here. This x square minus 4, x square minus 4 is common. So what I'll do is, you can remove 8 as well, but I'm not going to remove that. I'll leave that 8 as it is. What I'll do is I'll just remove this x square minus 4 and x square minus 4 out. So if I remove x square minus 4, one term, what's going to happen? It's going to be minus 8 times x square minus 4 here. See, out of the 2x squared, this power 2, that means 2 terms like this. 1 is gone out, so only 1 remains. Minus 8 remains, plus this is gone. What is remaining here? 32x squared. That's it. Divided by x squared minus 4 the whole power 4. Now this cancels with one of it, so it will be power 3 here. Now what I'll do is, when I'm writing this, I'll even multiply this minus 8 inside now, because I can't remove anything further. So distributive property. It'll be minus 8x squared. Minus and minus becomes plus 32 plus 32, this right term, x squared divided by this entire thing divided by, so this is with the line, x squared minus 4 the whole cube. This is how we get it. Then what is the next step now? Here we can just simplify this, and denominator is done. Don't do anything because it's cube. See, it's just like this. Can you see this x square minus 4? The whole square doesn't matter. Only what is inside, that's x square minus 4. That equated to 2, you will get x plus or minus 2. These are confirmed. But what about the numerator? Let's solve it now. I will simplify. 32 minus 8 will be 24 x square plus 32 divided by x square minus 4 the whole cube. Now what you need to do is basically the numerator and the denominator equated to 0. So let us do it in the calculator now. Now we have to put the numerator in the calculator and solve. Because it's quadratic, you can go mode 5 and 3, and let's solve it. It's 24 0 32. Okay, it's all positive. It might be imaginary now. See, you're getting imaginary numbers. I, whenever there is I, you just don't use those values. You can't consider those values because they're imaginary. So in this, only the denominator values will be there. That is plus 2 minus 2. No other values. Okay. So let's do the step 4. I'll just do it over here. So what happens is step 4 is this number line. I will have minus 2 plus 2. I need to choose test values for this. So I will choose test value as minus 3, here 0 and 3. Now I have to put it and find the signs. This is it. Remember, the numerator over here was imaginary. That's the reason we are not going to consider any others, only the denominator values. Now here you need to just put this equation as it is. That is 24 alpha x squared plus 32 in the numerator, and the denominator is alpha x squared minus 4 the whole cube. Type this as it is, the simplified version. We checked for equating 0. Above was imaginary, down we got plus and minus 2. So now we calculate the test values. Calc at minus 3. What is the answer? It is positive. We don't care about what's the value. We just care whether it's positive or negative. This is positive, and let's test for 0. It's negative, and let's test for the positive 3 as well. It's positive. So it was plus, minus, plus. This means it'll open upwards, downwards, upwards. This is the information we will get from the two number lines. From the first derivative is the first one. This is basically increasing. Let me just do the arrows over here. Increasing, increasing, decreasing, decreasing. Here, up, down, up. Now I'll just erase the left part. These two number lines are the most important in graphing. So since 0 and this both positive and negative, let me do it in the middle. 0. And looking at this given question, I know there is asymptotes at minus 2 plus 2. What happens? It'll be, there won't be any sort of graph over here. There can't be any graph. So over here, basically, let me just draw some straight asymptote over there and over here. There's only two asymptotes, vertical asymptotes. What about horizontal? I'll tell you a method to check it. You need to put the given equation for the step 5. This is the last step. Always use the given equation. So what you do is put this alpha x squared divided by alpha x squared minus 4. And now calculate at what? You need to find the limit, right? So calc at two corners, that's minus infinity, minus 999. There is other formula method, but I'm just telling the shortcut over here. It's 1. Okay, let's check the positive. It should be the same, or then let's check positive 999. It's 1 point. Okay, it's 1. So basically what we come to know from this is we are having asymptote at positive 1 over here. At positive 1, this graphs will come very close to it. It's like a limit. It'll come close. If something like this, it'll just come close to it. I really don't know what's the graph. We will graph it now. So this is some basic information. Now we don't have much values, right? So what you can do is you can use some test values. Okay, that would be much better for accuracy. You can take some -3 over here, -1, 1, +3, and you can graph it. Okay, this can be done. But now over here, I will just try to directly graph it, because from this information you can get a rough graph, but the values will be wrong, but you can do it by putting in the calculator, finding the values accurately and solving. But now I'll just do it directly. See, before -2 it's increasing, here also it's increasing, but and opening upwards. Yeah, so increasing and opening upwards. How can that be? Let's think of trials. So can I graph something like this? Because I know there's asymptote. I can't have graph like this and like this. No, that's not possible. It's only somewhere, one place, right? If I do anything over here, it'll be like this because these are asymptotes. This is decreasing, so this is not possible. Can I do increasing like this? No, it's asymptotes are there. So only possible way would be something like this over here. Okay, it'll be something like that. It's not accurate because I've not found the y values, but something like this. It goes on because it's increasing. Now this is increasing here, and this asymptote I have managed it to satisfy the conditions over here. Asymptote and this. Now next one, 0 over here. You can see till 0 till -2 to 2 it's concaving downwards, but from minus over here, from sorry -2 it's increasing. That means it should come like this. It'll have a maximum point here, and then it's decreasing. It'll be something like this. I just saw this equation and I realized at x is 0, it's very easy to solve. 0 and 0, what remains? 0 divided by anything will be 0. 0 divided by -4, it's 0. So I have made until, the 0.99, I guess. 0.9. This is wrong what I did. You should know that here, if you substitute 0, you will get maximum value as 0. So I will just correct the graph. It'll be something like this. It'll come over here, it'll touch maximum point and then it'll decrease. So maximum, it'll touch over here 0. Why? How do you know? Just put the value x is equal to 0 in the given question, this first equation f of x, you will get the y value. I've not done that because I'm just drawing a rough graph. So this is this part. There's no way I can draw it upwards. Why? Because it's opening downwards. This is the only possible way. I can't draw it like this over here because there are asymptotes. It'll contradict. Next one. Last one, it's going downward. It's decreasing and opening upwards. I can't do like this because this is an asymptote. So it should be free to move upside, right? It should be like this and over here. Now, if you're thinking why I didn't do it like this, over here, this is an asymptote. I can't touch up, right? So this, if it was down, it can only be like that. But that will be increasing. I need a decreasing graph. This is decreasing and it's opening upwards. See, this is opening upwards. So this is the rough graph we can get from this. So if you have done the step 1, 2, 3, 4, this will be the step 5. This would be the graph, rough sketch of graph. See, these are the values. Let's compare graphs. See, the computer generated is not so accurate over here. You can see over here as well. But the final graph, see, this is more like it, what we have got, As I've not done accurately any values, but you can take some values and graph them and you can get it. You can make a table of values also. It's up to you. But approximately this would be the answer. We move on to the example 6.4. This is the function given to us 1 by x cube and it goes on. We need to draw this and show all the significant features. Now the steps are just the same what we have done already. But the problem over here, it's not a problem. It's just that the hard part is the derivation. You need to derive it once and then twice. So this becomes a bit tiring. But if you know derivation, then you can go ahead. But it is very important you simplify the problem as you go. Let's start this problem now. Step 1, I will directly start deriving it over here. F dash of x. I know this is in terms of 1 by x. So derivation of 1 by x is minus 1 by x squared. So I'll use this rule directly. It'll be 1 by divided by over here x cube plus 3x squared plus 3x plus 3. And then this is done. It's a chain rule. Sorry, whole square, I forgot. Now it's a chain rule. That's whatever is inside needs to be derived. It will be 3x squared plus 6x plus 3. You need to be thorough with derivation, otherwise it's very hard. Now here you can continue over here solving the numerator denominator. It's possible. I've tried the long method. It's just that it gets very tricky later on if you leave it like that. So follow the simplification. Now here, if you put this in calculator, you will get an answer x is equal to, right? But before we put it into calculator, I can see there is a common term 3. You need to first simplify this. If you just want the answer, it's fine. But now here I will remove, because I need to use this later on. So I will first remove all the common term. That is, 3 is the common term. It will be minus 1 times 3. It's minus 3 into x squared plus 2x plus 1. I've removed 3 throughout, divided by x cube plus 3x squared plus 3x plus 3 the whole squared. Now this is the simplification. Now here there is one more step. You need to take out your calculators for this. All you need to do is the numerator, the equation x squared thing. You can solve by mod 5 and 3. Let's put the values. It's 1, 2 and 1. Here, if you press, you'll get only one answer, only x. There's no x1, x2. In fact, in quadratic, you must have maximum 2 values. But if it's only 1, that means in reality, the graph, right, is touching like this at minus 1. So it's touching over here. This means you will have a multiplicity of 2 at that particular point. So I'll just write it here. X is equal to minus 1. What does that mean if you take it inside? It's x plus 1. This is the factor. Now I can simplify this as minus 3 into x plus 1. But don't forget, since it's the only answer, you should put whole squared. And below is as it is, x cubed 3x squared plus 3x plus 3 the whole squared. Now what do you do is, see, this is having squared, this is having squared. Minus 3, let's remove it outside. And let's write x plus 1 divided by x cubed. So all you need to do is this x power 3. Then this entire thing, 3x squared plus 3x. And you have over here plus 3. Now it's all a whole square. See, this entire thing can be squared up together. So this is a simplification that we are using. So now this entire thing can be used up. It can be used up together for the square. This simplifies a lot, because as you continue to further derive this double derivation, this makes it a lot easy. It's not like you cannot do it over here. You can apply power rule and quotient rule and solve, but it goes very longer. So this will be a bit shorter and easier to understand. So now we stop here. You can even stop over here, but now this is done. So the square doesn't mean it's fine, but now we have to just equate equal to what? 0. This numerator here and the denominator must be equated to 0. I'll just put it in another color here. This term over here must be equated to 0 and the denominator also equated to 0. You need to solve it in the calculator. Let's see, the numerator is very simple. It's just x is equal to minus 1. That's it. But what about the denominator? Mod 5, 4. And let's solve it. 1, 3, 3, and 3. We got 2. Let's start doing the step 2. That is the number line. I'll just start doing the number line as well in the meantime. Here, let's draw a straight line. And then we have, over here there was minus 1. X is minus 1. Let me put it over here. Minus 1. Minus 2.25. It's 2.26. And let's see the other things. Look here. Whenever you are plus like this, it means it's an imaginary number. No considering this number. Even imaginary numbers will always be in pairs. If you have 1, you must have 1 more. It will be a plus and minus. So please don't consider these two. Only one value, that is minus 2.26 is the answer. This is undefined point. Even over here at this, there will be an asymptote at minus 2.26. This one is from the numerator, so it's not an asymptote. Over here, just that value. Okay. Now, what do you do next is check values. So you need to test some values. Let's take, say, minus 3 here. I will take over here as minus 1, minus 2 you can take, or 1.5 and 0. And I will substitute over here in the given, in the derived equation. So it's up to you. You can choose this. I'll choose the last one. Let's go to the computation mode. And minus 3 is outside. Minus 3 multiplied with, okay, I will use the bracket here because it's whole square. Alpha x plus 1 divided by alpha x cube plus 3 alpha x squared plus 3x plus 3. And close the bracket over here and square it up. Now what you do is you need to press calculate at different different values. This is at minus 3. Let's calculate what's happening at minus 3. It's negative, so I'll write minus here. Let's do the others as well. Afterwards we have minus 2, or you can take minus 1.5. It's again minus. And last one, calc. Let's see, at 0 it's minus. All the three are minus. Okay, they're all decreasing. So it's minus, minus, and minus. So everywhere it's decreasing downwards. So this is the graphs. It's all decreasing. That's fine. Now, what about the next derivative? So now you need to derive this again, double derivative. It gets crazier. It's just that you should be thorough with derivation, then it's fine. Now, f double dash of x. What happens over here? See, what I would personally do is use this power rule. And this is the easiest of all because I even tried the other method. Okay, I used this over here somewhere, one of the step. I've used quotient rule and tried, but it gets difficult as we go on. So the best and the easiest one is over here itself. So let's stick to this. Here minus 3 is the constant. This becomes power rule. So this 2 comes down. Imagine you add x squared. It will be 2x, right? Same thing. This entire term, write it out over here. X plus 1 divided by x cube plus 3x squared plus 3x plus 3, and then whole power 1. But then there is whatever is over here, you need to derive this again. Now for this you need the quotient rule, u by v, that is u dash v minus uv dash divided by v squared. So this is the thing, chain rule, sorry. This is quotient rule, but this, after taking the power rule, we have to derive inside. That is the chain rule concept. It'll be 3x squared plus 3x plus 3 the whole square. And what about the numerator? Derive the first term. It'll be 1 multiplied by the denominator as it is, x cube plus 3x squared plus 3x plus 3. Then multiply it with what? Minus, what is u? U is x plus 1 into, what is v over here? V dash, derive this. 3x squared plus 6x plus 3. Okay, this is the thing. Now you can see all are in multiplication, the numerator denominators. It's fine. Now you need to just start simplifying. You need to multiply everything over here and simplify it. Now before we start simplifying, this, all the numerators, see there is no plus, this is single term here, this is a single term, everything can be multiplied, okay, but make sure this is all in single term. You can multiply this minus 6 here, it's fine, but everything over here is a single term. So how would you solve this? Is 1, it's fine, leave this. This x needs to be multiplied throughout and this 1 needs to be multiplied throughout. I will just solve this part separately. Okay, over here I'll just separately solve it. See, x is multiplied here, what happens? It will be 3x cube. Then it is multiplied here and over here, same with 1. I need more space, so I'll just write it over here. It will be 3x cube plus 6x squared plus 3x. Then this one, okay, 1 is multiplied plus 3x squared plus 6x plus 3. Now if you simplify this, it will be 3x cube, and there is 6 and 3, it will be plus 9x squared plus 9x plus 3. So this is the simplification over here. Now look at this minus sign. That means this entire thing is multiplied by minus. So what happens is this whole thing will be minus minus minus. Let's solve this. First, let's only focus on the right side, okay? This part only. The numerator is x cube plus 3x square plus 3x plus 3. And now this entire thing is minus. So it is minus 3x cube minus 9x square minus 9x minus 3 divided by this square x cube plus 3x square plus 3x plus 3 the whole square. Now look here, many things cancel, right? Not many things, only this thing cancels. And now you can simplify it further. This becomes the numerator x cube minus 3x squared becomes minus 2x cube. Okay, minus 3 plus 1, it's minus 2. And this, what happens is minus 6x squared. Why? Because minus 9 plus 3 is minus 6. And lastly, we have again minus 6x. This is the thing. Now, what you can do is, see, this is a single term, so no need of touching this. Don't multiply this inside because already you have x plus 1. We can equate it. It's single term. This is solved. But here you can take something common out, the numerator. The denominator is same here, okay? So this denominator will be the same even over here. But the numerator, what I can do is, I can simplify it. See, now even this side, left side, only thing is over here, it will be minus 6, 3 times 2. And this as it is. Okay, I just realized one thing. This is power 1 and this power 2. I will show it in a while what happens. But now look at this one. This can be simplified further. Only this right side I'm simplifying because this is the tricky part, right? Now minus 2 can be removed out. What happens then if you remove minus 2 outside? You're remaining with, and you can, sorry, not only minus 2, you can remove x as well. So you can remove minus 2x out. What's remaining? It'll be only x square plus 3x plus 3. This is what's remaining. Okay, so I will write this above. I'll just clear the above part and write it up. Now here from the left side it will be minus 6 f double dash of x will be equal to minus 6, and then we have x plus 1 numerator, then denominator will be, see, this is power 1, this is power 2. I'll multiply them together and write. Instead of writing two denominators, I will write this as x cube plus 3x square plus 3x plus 3 the whole cube. Why? Because they both are denominators, they're multiplied up, right? So you can add the powers up. So this is what happens. And this term entirely, I'll write it over here, multiplied by minus 2x multiplied by x squared plus 3x plus 3. So this is all together. Now this is multiplication, so it doesn't matter. You can write it up over here. Only when there is plus, it's separate terms. Nowhere there's plus, it's all terms, factors. So what I'll do is, this minus 2x I'll multiply up over here. So it becomes minus minus plus 12x. 12x. Next term is x plus 1. What is this term over here? X squared plus 3x plus 3. Then denominator is x cube plus 3x squared plus 3x plus 3 the whole cube. So this is basically the simplification. I think so you can go simplifying this further and all, but it's just too much. This is more than enough. No need of multiplying this again. You will get one more term. No need, just stop over there. So here now we can stop and start using the calculator and getting the number line. Let me clear up the other things. Now using the calculator we know this x is equal to minus 1. Let's solve this one over here because the denominator we have already done the same thing. It'll be minus 2.26 and two imagined numbers. Denominator is fine. The numerator, this one, mod phi 3. It's 1, 3 and 3. Let's see what's the answer. Both are imaginary, so you can ignore this. We know x is equal to minus 1, but there is one more x. This only x means it is equal to 0. See, what we basically do is, whenever we are solving each term. X plus 1 is equal to 0. So, and then we are equating x will be equal to minus 1. This is how we get it, right? Here 12x is equal to 0. What is x? 0. 0 divided by anything is 0. So that's the thing. So if you're doing the number line now directly, what happens over here is you will have this minus 2.26 is same, minus 1 is same, and remember to add 0. Now here the test value minus 3, minus 2, minus 0.5 or half, and you can take it as 1. Now we will have to use the calculator here. Put this equation. Let's go to computation mode and put this entire thing. 12 alpha x multiplied by, use the brackets appropriately, alpha x plus 1. As it is, you can write it out. Even if you don't put this multiplication symbol, it's fine. I'll remove it because I just type it however it is. Okay. Wherever x is there, you should press alpha and x. Now again, alpha x square plus 3 alpha x plus 3, close the bracket. And over here we have alpha x cube plus, sorry, you should press next, plus 3 alpha x square plus 3x, and lastly plus 3. Now don't forget the power. See, I have not used the bracket over here at the beginning. Let's use the bracket, and then power 3. So basically you have to just put over here, not power 2, it's power 3. Okay, this is the entire equation what I've written over here. Now calculate these test values. At minus 3, what's the answer? It's negative. So let me write over here, it's minus. So it'll open up downwards. Now what about the other test values? When I calculate at minus 2, it is positive. If it is positive, it will be upwards over here. I'll just write positive. And then here let me check at 0 minus 0.5. Again it's minus plus minus plus minus, I think so the last one will be plus. Let me calculate at 1 plus. So we get alternating signs, minus plus minus over here, and last one is plus. So it's upwards, downwards, upwards. So this is what you get in concavity. So now if you want to graph it, let's just take a rough graph. This is the scale. Sorry, let me write this over here because it's mainly the left side, right? This is 0. This side it's not there. Minus 1 is over here. Minus 2.26. I know this is an asymptote, so it will be a vertical asymptote. It should pass by 2.26 accurately. Just doing a rough one. And what about the this is the last step. What about the horizontal asymptote? How do you check? You need to put the given equation in the calculator. Use this 1 divided by, type the given function, that is alpha x cube plus 3 alpha x square plus 3x plus 3. Now this given equation, what do you have to do is calculate it at a huge negative number towards minus infinity. What's happening? It's showing minus, it's 0. Okay, why? Because it's minus 10 to the power minus 15. Let's calculate the right side. It's 1 into 10 to the power minus 12. It's 0. So you will have a horizontal asymptote at 0. So at this point there won't be any value touching. So I'll just draw dotted lines over here. So basically over here it's an horizontal asymptote. So that much information is more than enough now to graph the basic graphs. It's decreasing before 2.26 and it's downwards. So decreasing and downwards can only be like this. So it should be something like this. You can't have this part above. It's not possible. Now what about the right side of it? It's decreasing but it's upwards. So yes, it's decreasing. It should be like this down. You can't have it over here. It should be decreasing but down like this. Okay. And again it's decreasing but it's upwards. So when it comes to minus 1, it changes until 0, and then okay, this is a little bit tricky. Now over here there is no much information, it's just decreasing. So what you need to understand is Here it's decreasing, yes, but here, from here, it increases like this, changes, sorry, and increases again. Okay, just slightly, it goes something like that. Okay, slightly. This is not accurate because I have not taken the y values. We have done it in the previous problems. You need to choose, you need to, put calc in this instead of x. You need to choose all these values and find the y values, and then accurately you can graph. But now I'm just telling you the rough sketch of the graph. It won't be like this, but I know it will be something like this downwards. It's all decreasing. It See, this much should be facing upwards, then, sorry, it's not too much, but this part will be downwards, and then this part again will be upwards. I hope you understand the difference. Because of the concavity, you need to follow that. Let's look at the final graph here. See, if you use the graphing calculator, you'll just get like this, which doesn't give much information. So let's see the final graph. Where do we have it? Okay, here. Now what I did is not that accurate, but it's close enough. See, can you see this? Upwards, downwards, upwards. The asymptote is at zero, so it keeps on going towards that. You can see upwards, downwards, upwards. This deviation, but these two figures, these number lines are the most important thing. You can see the number line down, up, down, up. Here it was decreasing, decreasing, decreasing. Everywhere throughout it's decreasing. But this parts, these two will tell you a better understanding of the graph at these points. So that is how we basically solve this problem. The tricky part over here is the derivation. The other steps are the same steps, nothing much in this. You can, find the asymptote by taking the limits. That's the thing. And over here now we have exponential e. Again, similar method, nothing much. It's just that the same method, derivation is important. Let's do this as well. You can pause the video now, try it by yourself, and then continue. Let's start this one. I'll directly try to solve it. First, let's derive it. F dash of x. How do you derive this? When you derive this, you should have derivation of e is the same thing. There is nothing over here. It will be e to the power 1 by x itself, but then derive 1 by x. It will be minus 1 by x squared. This is the derivation. Now here I will write it in terms of fractions. It will be minus e power 1 by x divided by x squared. What I'll do is I'll double derive this again now only. You can do it in various methods, but what I would do is I would do product rule now just to show you. See, I was telling you I can do quotient rule. It's fine. It's the same thing. But I was telling you can bring this up and do product rule, right? I'll just do that one. This minus sign, I'll leave it outside. Let that be outside. And then now this term remains e 1 by x as it is. But this denominator, right, will come up. It'll be this x doesn't become minus, the power becomes minus 2. Okay, that's the only thing. See, it'll be x. Here, instead of positive 2, it'll be minus 2. That's the thing. So this is how we get it. Now you can see it is u and v. So u, v. How do you derive uv? The first derivation u dash into v plus uv dash. This is what we get in product. This is the formula for product rule. Now you need to do the same thing here. The minus is outside. So over here what we will have is derive this e to the power 1 by x into minus 1 by x squared. This is the same derivation multiplied with the second term as it is, x to the power minus 2. That's it. So that is the first term done. U dash v is done. Plus, now first term, just write it like that and derive the second term. It will be minus 2 into x to the power minus 3. This is what happens. Now if you rearrange and write this up, see, first I'll take this common out. Minus e to the power 1 by x. 1 by x is common. I'll just remove it out. It will simplify my work. And now here, I know this can be, taken down. It will be basically minus, let it be 1 by x squared into 1 by x squared. Why? Because this minus 2, if I take it down, this is the thing. There are 2 over here. Plus 2 remains. I'll just write 2. This is minus, okay? So it'll be, I'll just change the sign now. It'll be minus 2, and this is 1 by x cubed. This is the thing. Now, this minus sign can be multiplied inside because both are minus. So what happens is when I multiply inside, both will be plus. That is easier. And what about this term? This term will be, I'll just write e to the power 1 by x. Here, 1 by x square and 1 by x square is basically 1 by x squared the whole square. Or 1 square by x square square is power 4. 1 square is 1 by x to the power 4. So this is the thing. Directly write it over here. 1 by x power 4 plus, because minus has been multiplied, both will become plus 2 by x cube. This is the answer. Now here, how much terms can be removed out common in the denominator? Power 3 can be removed out. So it will be e to the power 1 by x divided by x cube outside. What's remaining is 1 by x plus 2. And now this can be written as e 1 by x divided by x cube into multiply x and x up and down. It will be 1 plus 2x divided by x. And now this x again can be multiplied out. It will be x to the power 4. So it will be e 1 by x multiplied by 1 plus 2x divided by x to the power 4. This is the simplified version. Now this is simplified, yes, this is the first derivative, this is second derivative. Now I did these both derivations together because it's easy to understand 1 and 2 derivation. First derivation was so simple, but second derivation, look, all complication. Now let's do the number lines. For the number lines, we need to, first find the x values. So how do you find the x values? Numerator and denominator must be made equal to 0. See, exponent to the power, any x value, you will never get 0. You will get some value because what is the exponent graph? There's no 0. It will just keep on going. It's always more than 0. It should be greater than 0. So there is no way the numerator will become 0. It's not equal. See, this is not equal to 0. But this, yes, can be equal to 0. So x is 0. Only one value here. What about the next one? This part, no, it cannot be equal to 0. What about this? 1 plus 2x is equal to 0. So what is x value? X will be equal to, 2x is equal to minus 1. X is equal to negative half. This is one value. And here, denominator, x is equal to 0. So these are the x values. So I will graph it out. So let me just do the number line. For the increasing and decreasing, it will be something like this. Only 0. So I have to take minus 1 plus 1 as the test value. Let me do the other number line and then I'll do the test together. 0 here and minus half. These are the 2 points here. I can take it as 0.25 minus 0.25 as test value. And what about this over here? I can take minus 1. I can take 1. Now this is f dash of x, f double dash of x. Always the first step is always related to the first derivative, second number line, second derivative. Here concavity, here increasing, decreasing. Let's take our calculators. First, let's do the first derivative. I will put in this equation, that is shift and e to the power 1 by alpha x. That's done. Divided by alpha x squared. The sign, negative sign, don't forget it, minus. So let me put this, calculate at, see, both will be minus 1, okay? Minus over here, and let me calculate it at 1. See, both will be minus because no matter what, I'll get one value, but because of this minus sign, both becomes minus. This above, both are minus. Let's do the next one over here. It's shift and e to the power 1 by x, 1 divided by alpha x, and multiply it with 1 plus 2 alpha x, close the bracket, divided by alpha x to the power 4. Now calculate at x is equal to this. These are the test values here. Above both were minus. Let's check this. Minus 1. It's minus again. Till now everything is minus. Calc at minus 0.25. We get plus. So let me just start writing it. Here it was minus, minus, minus. This is plus. And what about the last one? Let's check this one. Calculate at 1. Again we got plus. So this is plus. Okay, over here, this entire region is plus, this is plus, minus, minus. So decreasing, decreasing, sorry, not decreasing here, it's concaving downwards, uh, like this, upwards, upwards. Now I'll erase the left side and we'll graph it. To graph, let's draw the coordinate plane first. So here main, let's just draw a random thing. Over here 0. There is minus half and minus 1. Okay, those are the important points. Over here there's only 0. Over here 0 and minus half. Sorry, minus 1 is not required. What I'll just do is, for better clarity, let me just take this as minus half. There's enough space. So now let's see what's happening here. Exponential function at 0, it is always asymptote, so I can just do that. Asymptote is over there and it's decreasing. See, over here it's decreasing. Oh, one more thing, can x be 0? 1 by x, if x is 0, x cannot be 0. Why? Because it'll be undefined over here. So we have another vertical asymptote. See, whenever you have denominator of divide by x, this will be an asymptote. Now here it will be x cannot be 0. So these are the asymptotes at 0 over here, horizontal, and vertical also at 0. Now let's see the point minus half. So before minus half, it'll be decreasing and downward. So it'll be something like this. Okay. And here decreasing, but it's upwards, so this will be changing, it will be going like this, something. Okay, see, I have not done the graphs, I'm just doing the basics of exponential. I did not check the y values. You can test any value of x and you'll get the accurate values. Please graph it accurately, but I'm just doing it roughly because we have done many times already. So this is upwards, this is downwards. Now after this, after 0, again it's decreasing but it's going upwards. So basically, because I know the asymptotes, I can just tell that it's going something like this only. It can't be down because this is an asymptote. So it's decreasing. So it should be something like this. Okay. Now again, this is not at all accurate. I have not taken any y values. I've randomly graphed. Let's just look into the graphs. See, this is what comes up in the graphing calculators, but we don't want that. Let's look into this one over here. Okay, this one is a better understanding. See, till 0 minus 0.5 minus half, you can see it is like this. Whereas, see, over here it's like this. Whereas last point, it changes its concavity. That's what I try to do over here. See, let me just take it. See, it's concaving downwards, then upwards. That's what it's been trying to show even over here in this graph, downwards, upwards. And what about the right side? Because of the asymptotes, we can easily guess it's coming like this. But how do you get these accurate values? It's by finding the y values by putting these x values in this given equation. You can find different y values. So this is how we graph this. Now it's not very accurate, but it's close enough. All the important points are noted over here. It's just that I've not done it accurately by graphing the y values and all are unknown. But if you do that, then you'll get very accurate graph. So that's about that problem about exponential function. Now last one is trigonometric function, and this is the last problem of this lesson. It's been a long one. So we need to draw the graph for cos x minus x, showing all the significant features. And these they have just given, I guess. Now this is something like this, but we have to graph it by ourselves, okay? Just if you have this graph, it's not enough because we need the concavity where it's up, down, increasing, decreasing. That is very important. So let's start graphing. Same steps. What you do basically, first step is always derive it up, f dash of x. When you derive this, cos is minus sine x derivation and minus 1. Now you need, this is it, okay? There's no much simplification here. You need to equate this to 0. So when you equate this to 0, what happens? This goes to the other side, will be minus sine x is okay 1. I did the wrong thing. Let me just change the signs. It'll be sine x is equal to minus 1. Now, when is sine x is equal to minus 1? You can do it in different ways. One thing is if you know the unit circle. So if you know the unit circle, 0 and 1 of cos and sine is only at either 0, 90, 180, or 270. So first is always cos value, x is cos. So it starts with 1 comma 0, and over here it will be 0 comma 1. Now over here again it will be, you can see, if you don't want this unit circle, you can just use the calculator and find it also, but I'll just do the basics, only 90, 180, these graphs I'll do it over here. Now from here it's 0, again it'll go over here, it'll be minus 1, and this will become 0, and the sine will become over here again 0 comma minus 1. So at 270 degrees, only at 270 degrees sine, see, sine is y, xy, it's cos theta sine theta. Only over here you get minus 1. So now sine x equals minus 1 is at, this is 0, 90, 180, 270 degrees, and back to 360. Uh, x will be, this x value is equal to 270 degrees. Now this is in terms, because it's trigonometry, it's in terms of degrees, but you can do radians. I'll show in the calculator how to do it now. Now you have sine x equals minus 1. So we can, now generally it's better to keep it in radians because degrees won't give better understanding when you're graphing and stuff. So I will just change the mode, shift mode to radians, 4. Shift mode and 4 makes it radians. This is R now. Now you can do sine inverse of minus 1. What is the answer? It's negative pi by 2. Pi by 2 is basically 90 degrees, but it's showing minus 90. See, minus 90 from 0 minus 90 means it's 270. 360 minus 90, how much is it? It's always 270 degrees. Now here the problem is negative pi by 2 is not what we would like to write. We can write 3 pi by 2. Or how to find the coterminal angle is plus 2 pi. You should just add 2 pi or subtract 2 pi. Now since it's minus, I will add 2 pi. This is the answer, 3 by 2 pi. So x is 270 degree, or x is equal to 3 pi by 2. Okay, this is in radians. Now, if you know the sine graph, when is sine exactly at minus 1? Sorry, that's a bad line. It's, if this is 0, it starts at 0, it goes up, it comes down, it keeps on going, and even over here. So if this is 0, this is 1, this is minus 1. Look here. All these are minus 1 points. There's everywhere there are minus 1 points, isn't it? So at these particular points, x is the answer. Now you can't keep on writing x is 3 pi by 2 minus pi by 2 and again add pi by 2 and keep on writing. No, what we basically do is we just do plus k, that is the integer. K is any 1, 2, 3, minus 1, 2, 3, any minus values or positive integers only, into 2 pi. Or this over here you can write 360 degrees multiplied by k. This is the thing. That means it keeps on repeating. That is what you're saying over here. So this graph basically goes infinite. You saw the graph at the beginning, right? It keeps on going. That's the thing. Now this is just the first derivative. This one. Now we found the x values. We need to do double derivative. That is f double dash of x is equal to, what happens? This is to be derived. Sin x derivation is cos x, but minus sign remains cos x, and that is 0. This is it. So make this equal to 0. Cos x is equal to 0 at what time? Over here I have it. So it's either 90 or 270. See, now the problem is, if you know these values, it's very helpful. If you are using the calculator, you'll just get one answer. So it's better to know these values. Only these, if you remember, because these are very important values. Now x will be equal to how much? It will be equal to 90 degrees and 270 degrees. Okay, or x is equal to, if you do it in calculator, you'll get pi by 2, or it'll be same thing, 3 pi by 2. Okay, 3 pi by 2. So now this is the answers. I will just show you over here. You can do shift cos inverse. What is this? 0, right? Cos inverse 0, that will be the x value. If you take cos inverse on both the sides, it's half pi, that's pi by 2. But it won't give you the other answer. Now, if you want the other answer using Table method you can get mode 7. This is just for extra understanding. You can skip this part. Mode 7. Now here you need to type cos x, cos alpha x. Okay, this will give you the points of cos x at any points you want. This is only one equation you want. Let's start from say 0 and end it at 2 pi. Okay, because I have 2 pi, that's in radians. Sorry, let me just put 2 pi or 360 degrees. And what is the step? Let me give a step of 45 degrees, that is pi by 4. Okay, so it is pi, that is shift pi divided by 4. Now it tells me at where, at 0. Now this is pi by 4, that is 45 degrees, or pi by 4. Okay, it's so much value. Now pi by 2 is given as 1.57. If you solve pi by 2 and press ST, you will get 1.57. So this is in radians or 90 degrees. Sorry, yeah, 90 degrees. Yes, it's 0. So we got 90. And then where else? If we scroll down, we are getting one more 0 at what? 4.71. Now, if you do 3 by 2 pi, you will get 4.71. I'll show you 3. Let me take it off. Let's go back to computation mode. 3 pi by 2. What is the answer? It is 4.71. So, we got two answers only. That table, entire table from 0 to 360, it will be only two values. Okay. But now here you must remember this will be k plus k into pi, because every 90 degrees these repeats. See, 0 is every at 90 degree. It cuts 0. So this is one thing you must remember here. This is sine graph, but cos graph also it's similar. It just starts over here, and you should know that. So these are the x values we got, and they keep on repeating. Now then, what we will do is we will do the number lines. I just erase this parts at the right. Let's do the number line for the first one first. Let's do both the number lines and then use the calculator. So over here it is uh, this is 90, this is 3 pi, somewhere over here 3 pi by 2. This is for the first one because that's the only answer. So the test value can be anything like less than 3 pi will be pi by 2. It's 1.5 pi. I can just take pi as well instead of this. I can just take not negative, sorry, I'll just take positive pi here, and here I'll take 2 pi. Easy to calculate. Now same thing with concavity. What are the values? One is 3 pi by 2 and one more is somewhere over here. I'll write pi by 2, that's half pi. So what I can do is less than this will be 0 pi, that means 0. Over here it's pi and here it's 2 pi. Now this is f dash of x, that's the first equation, and over here it is f double dash of x, that's this equation. Now we have to use our calculators and check the test values. Here let's first do the first graph. Minus sine alpha x, close the bracket, minus 1. Now what is the test value? Calculate at pi. Shift the symbol pi. What's the value? It's minus. So all you need is the sign. It's negative here. Now what about the next one? It's 2 pi. So calc, next test value, it's 2 pi. It's again minus. So this both are minus, negative and negative. That means it's decreasing. And we had seen the graph, right? It was decreasing throughout. That's correct. Now what about the other things? You need to change the equation first. It will be minus cos alpha x. That's it. Now equate this, test it at different values, calculate at 0 first. Here we got negative, again negative, calculate it at pi, that is shift and this symbol. We got positive, so we got first minus, plus, and then last test value over here was 2 pi. So I'll just calculate it at 2 and pi. Oh, it's minus. So plus minus plus, minus plus minus, okay, minus. Now this is about the graph. Now I'll just erase this and we will just do the graph over there. Now over here you are to just graph these simply, nothing much. So we will start this from here. Pi by 2 is somewhere here. This is 3 pi by 2. Now if you convert this, if you press this in the calculator, you'll get 1.57. So you can take this as 1.57, this as 4 point, up to you. You can find the y values, just put the x values here, pi by 2, put pi by 2 and solve, you'll get the x values. Even you can go behind. Why? Because you know that always the minimum point, whatever the minimum, or this point over here, critical number, will be at every 2 pi. So even if I go at minus pi by 2, here it will be the same graph. But we are not, we will just do for this part, that is more than enough, and it continues. The point is it keeps on continuing. Okay, less than 3 pi, what is going to happen? So first let's do less than pi by 2. It's decreasing here, decreasing here, it's down, up, down. Everywhere it's decreasing, but before pi it's like this. So I'm not sure about the y values, but it'll be something like this. Okay, and then until 3 pi it's again decreasing, but it'll be upwards like this, and then it keeps on going like this. Then we know again it'll downwards, upwards, downwards. It keeps on continuing. That's the main point. If you find the y values, you'll have more accuracy. See, this is the thing. See, now I've done it okay enough, like down, up, down. That's what happens, So that's the answer. Is, see, this is more accurate, more like it. See, this is how it goes. But my values are not there. Y values are not there. If you're just wondering how to do the y values, I'll do it for this one. All you need to do is put this given equation, whatever is this in the question, it's cos alpha x minus alpha x, and then what you need to do is calculate at these values. So calculate at pi divided by 2. What is it? Negative pi by 2, or so it's 1.57, negative 1.57. So you just put it over there and then graph it out. So basically, whatever I did over here is plus, which is wrong because it should be downwards. See, that's why the graphs, let's just look into a graph. So you can see at pi by 2 somewhere over here, right? 1.57. This is also downwards, okay? It's below this. Because I had not done the y values, I didn't get it accurately. But anyways, now if you want to check for 3 pi by 2, all you need to do is this given equation, calculate at 3 pi divided by 2. And what's that value? The answer over here is, okay, negative 4.71. You can see over here in this graph, it's something over here. Yes, it's negative 4 point, it'll be over here. Yeah, that's how we do it. 4.71 and 4.71. This is the accurate one. You should graph it at those points and make sure you see whether it's concaving down, up, or down. That's the thing. This is how we basically graph it. Now, if you just look at this graph, only this concavity I've done it, but this accuracy will be by putting the different x values in the given equation and solving it out. Now, that's basically it. Now, okay, one more thing. If you want to find the intercept, how do you solve the intercept? Is very simple. I'll show you now. In this given equation, right? Calc at x is 0. How much is it? Now this shows you 1, which is correct. Sorry, x is 1, it is y is 1. But how do you find this point? Over here, I just realized x value, they are finding x intercept. How do you find it is? Here, you can just put this as equal to 0. So shift and solve. What is the answer? Here 0.739. That's how we get it. So in the calculator it will give you directly, and now in this particular equation, it only intercepts once. Okay, that's it. So directly you can get it, that's fine. But only if they ask, you can just do that anyways, because they have just done it over here. You can just do that directly. But the most important thing in this entire thing is this concavity. As you can see, it's going down, up, down, then again down, up, down. This repeats, and every part of the graph is only going downwards. That means it's decreasing, and that's what we got in this step 2 and step 4, and then we can finally graph it. So that's basically end of this lesson. It's a very lengthy lesson. I hope you have benefited it. If you have found this useful, please do subscribe to my channel. Please do like my videos and share it with your friends. What I would highly suggest is practice more problems. Just make sure you solve these problems by yourselves. Be thorough with differentiation, and then this lesson will be easier. So I wish you all happy learning and see you in the next video. Bye bye for now.